Professional Engineers Canada, Professional Engineers Ontario Examination, National Examinations, December 2019, 16 CIV A4, Geotechnical Materials and Analysis, 3 hours duration. Professional Engineer Examination Canada, Professional Engineers Ontario, National Examinations, December 2019, 16 CIV A4, Geotechnical Materials and Analysis, 3 hours duration. So these are notes for candidates you can go through before you start solving. Question 1. Question 2. Question 3. Question 4. Question 5. Question 6. And these are the graph papers you will need during the exam. Also provided these charts for solution, and then data sheets for all information you need it during the exam. Okay. Now I'll solve this example or this question. Question 3. I'll solve question 3. A building shown in figure 2 is subjected to a loading of 100 kPa. Determine the vertical stress increase, delta sigma, at a depth of Z 3 meters below the base of foundation. So it is here at this point. At point B, sorry, it is at under this point. For part A, I, it is here. So he asks to find or to compute the stress increase under point B using the M and N coefficient method. Okay, for this method, M and N, we have this chart. This is the chart for M. You see, here is M and here is M. So it is called the M-N method. Now, what is the meaning of this? How can I solve it? You see, for this method, the point must be under the corner. So for this case, I have two rectangles. As long as B is outside this, so here is the foundation. Here is the foundation or footing. And he asks to compute the increase in vertical stress under point B. So point B is, you see, it is outside this area, outside the foundation area. So I'll complete the rectangle. I completed here. So I got two rectangles. One is this one. This is large rectangle, and another smaller rectangle, which is this one. And I find the increase in vertical stress under point B from larger rectangle and deduct for this rectangle, because this area is not there. There is no foundation inside this perimeter, which is in blue. So number one, for how can I find for larger or for external rectangle? Now I'll compute N. N, what is N? N is X over Z. X is the length side of the rectangle. So it is 5 over 3. Z is the depth of point at which it is desired to compute the increase in vertical stress. So this one you can say it is 1.7. M equal this side. So it is 5 by 4. So it is 4 by 3. So it is 1.3. Okay, I'll go with these values 1.7 and 1.3. I'll go to this chart. You see, so here n is 1.7. 1.7, you see, 1.7 somewhere is here. It is an approximate solution. So here it is n 1.7. I have n 1.7, so it is around here. And I'll go vertically till I cut the M line. Okay, these are, you see, this line is M.5, this line M.4, 0.3, and so on. So I am looking for M1.3. So it is, you see, here it is 1.2, and this one is 1.4. You see, here M is 1.2, and here M is 1.4. So it is somewhere here between 1.4 and 1.2. This is M, approximately M here. See, I'll go here to read the value. So the value here are the values of I, the influence factor. So here, if you I is around 0.21. Okay, 0.21. Now, so the influence of this, or the increase in stress from the large rectangle, it is 0.21 the large rectangle, it is 0.21 multiplied by the loading from the building, which is 100 kPa. Here you can compute to be kPa. Now deduct this one, the same way, the same method. So here for small rectangle, also I have n equals this one, the length 3/3, and it is 1. M is this side, this side is 2/3, and this equals 0.7. I will enter this graph or this chart by this value and find another influence factor. Then deduct the increase from the larger minus the increase from the smaller rectangle. This is how I am going to do it. Come here to this chart.